Welcome to Science Lab with Mrs. Keener. Hi everyone. Good work on those egg incubators that you made. I saw people using padding and cushioning and hard shells to protect the eggs. Those were great ideas. And when I looked online to see what professional reptile people do, they use the same things because it's important to protect things that are delicate, because if they get dropped, they could get damaged or broken. That's because of the forces that act on objects. Starting today, we're going to be doing experiments with forces and how they affect objects. You might remember from previous years that forces are pushes and pulls. Today, we're going to do some experiments that show what happens when two things are pushing against each other. First, just take your hand and tap it against a table or a desk or the floor. Tap it lightly at first. You'll feel the surface that you're putting your hand on. Then tap it harder. The harder you hit the table or other surface, the more you feel it. And if you hit it really, really hard, you can even feel pain in your hand. You can hurt your hand. And that's because when you push on something with your hand, that thing pushes against you. If it's a solid thing. If it's mushy, you'll just push right through it. If it's delicate, it'll just fall apart. So we're talking about when you push on something solid, like the floor or a desk. When you push on something, it pushes against you. Some people say that for every action, there's an equal and opposite reaction. This was first described by the scientist Sir Isaac Newton. And we call this Newton's third law of motion. When something pushes against something, the other thing pushes back. For every action, there's an equal and opposite reaction. Find a place where you can do a standing long jump on the floor. Put something near your feet to mark where you're starting. Keep your feet together. Bend your knees. You can swing your arms to help you, but keep your feet together as you jump. Put something near your toes when you land to show how long your jump was. Do this a couple of times and choose your longest jump. The reason you can travel forward is because your feet push against the floor. As your feet push on the floor pushes against you, and you get moved forward. Let's try jumping off something slippery, though. It might be different. Put down a piece of paper and do the same kind of standing long jump. Bend your knees and try to jump. Keep your legs together. Can you jump as far? I sure couldn't. Try jumping off a thin towel. Try finding the smoothest, most slippery surface you can find. When I tried it, I couldn't jump as far. Try it in socks too, if your socks are smooth. Imagine trying to do this on an ice rink. The more slippery the surface is, the less it can push you. Try this on the most slippery, smooth surface you can find. See if you can jump as far. I sure couldn't. Next, we're going to build a tower out of paper. So get one piece of paper, like an 8.5 by 11 or notebook paper. It doesn't matter if it's lined or not. It could be scrap paper. And we're going to fold it. You can fold it however you want, or roll it, or crease it, tape it if you want. Try to make a tower that can hold up a book. Newton's third law says that if one thing is pushing against something, the other thing pushes back. So my book is pushing on my tower. If my tower is strong and sturdy, it will push back against the book, and it will hold it up. If my tower is too floppy or too mushy, it won't be able to push back and it'll collapse. Can you build a tower out of a single piece of paper that will hold up something like a book? If you can, try to put even more weight on it. How strong can you make your tower? How sturdy can you make a tower that pushes back, like in Newton's third law? Send me pictures or video.